Hi, in this video I was going to demonstrate some problem solving. I was going to solve some problems similar to the problems on your homework assignment. What I actually did is I took a few problems from your homework assignment and I changed the numbers. Um, that way I could show you all of the steps without actually giving away the answer. The first question on your homework assignment looks like this. It says that there's a small population of 4 people who have these 4 ages, and you're imagining that you're planning to recruit a random sample of 2 people from this population. You're going to record their ages, and you're going to calculate the mean age of your sample to estimate the mean age of the population. This question is asking, what's your standard error? These are the steps that you need to go through to answer this question. In step 1, you need to calculate the population standard deviation. In other words, you need to calculate the standard deviation of the 4 ages in the population. To get the population standard deviation, first you have to calculate the mean of the population. You have to add the 4 ages in the population and divide the total by 4, which is what I did here. That gives you the mean of the population, which in my case is 22. Once you get the mean of the 4 numbers in the population, you subtract each of the 4 values by the population mean, like I did here. The answers that you get from subtracting are your deviations, which I have right here. Next, you square each of your deviations. You multiply each deviation by itself, which is what I did when I created this column. -3 times -3 is 9. -1 times -1 is 1, and so on. Once you get the column of squared deviations, you add the squared deviations, and then you divide the total by the number of squared deviations. Remember that when you calculate the population standard deviation, you divide by n. You don't divide by n minus 1. So since I had 4 squared deviations, I'm dividing the total by 4. The answer was 5, which is my variance. The variance is really just the mean of the squared deviations. Then I have to go one step further and get the square root of my variance, and I get my standard deviation. So I took my variance of 5, I got the square root of 5, and my standard deviation was 2.236. That's my standard deviation. And the symbol for population standard deviation is sigma. That's why I put sigma right here. Now that we have the population standard deviation, we've finished step 1. Now we can go on to step 2, which is using the standard error formula. There's 3 different symbols in the standard error formula. There's the population standard deviation sigma, which we found in step 1. There's little n, which is sample size, and there's capital N, which is population size. We just have to plug in all of those numbers. In step 1, we found out that sigma, the population standard deviation, is 2.236. That's the standard deviation of these 4 ages in the population. So we plug that in right here for sigma, 2.236. And then little n is sample size. In this question, I'm saying that you're planning to randomly select a sample of 2 people from the population. So your sample size will be 2. That means little n is 2. That's the sample size. And capital N is the population size. You're going to be taking your sample of 2 people from a population of 4 people right here. So the population size is 4. Capital N is 4. Once we plug in sigma, which we found right here in step 1, the population size and the sample size, we just go through the steps and work out the answer. First, we just subtract inside of this square root. We subtract on top and we subtract on the bottom. 4 minus 2 is 2. 4 minus 1 is 3. So we end up with 2 over 3 right here. We divide 2 by 3, and we get this answer right here under the square root, 0.667. That's rounded to 3 decimal places. And then next, we just take the square root of this number, and we end up with 0.817. The square root of 0.667 is 0.817. We also need to take the square root of 2, which is 1.414. And at this point, we don't have any more square roots because we took the square root of this and we took the square root of this. Now we just have to divide this fraction, divide the top by the bottom. This number divided by this number comes out to 1.518. And now we just have 2 numbers we can multiply, and we get our answer. The standard error is 1.24. That finishes part A. The first question on your homework also has a part B, which asks you to find the standard error if you were planning to randomly select a sample of 3 people from the population. When you get to part B, you don't have to do step 1 over again, because we already know what the population standard deviation is. We already know it's 2.236. And the whole point of step 1 was just to get this population standard deviation. So, since we already have it, we don't have to do step 1 over again. In part B, you can just go straight to step 2 and use the standard error formula. You're going to plug in the same standard deviation, which you found in part A. In my case, it came out to 2.236. You're going to plug in your same population size of 4 for capital N. This time you're going to plug in 3 for little n, because now your sample size is 3 instead of 4. And you'll just work out the math the same way. Inside the square root, you'll subtract on top, you'll subtract on the bottom, and you'll get a fraction like this. You'll divide the top by the bottom of the fraction. You'll get one number under the square root. You'll take that square root, like I did here, to get 0.577. You'll also take the square root of this little n on the left side, and it'll just become a number on the bottom of this fraction. Next, you'll divide the 2 numbers inside this fraction, divide the top by the bottom, and you'll get a number. Then you'll just multiply the 2 numbers that you're left with, and you'll get your answer. That'll be your standard error. So this is how you'll do part A and part B of the first problem. I also gave you a standard error problem in which the population standard deviation is provided inside of the question. Notice how in this question right here, it says that the heights of this population of people have a standard deviation of 2.8, because I changed the number to 2.8. If the population standard deviation is provided to you, you don't have to do step 1, because you don't have to calculate the population standard deviation. You can just go straight to the standard error formula. So you'll just, when you see a problem like this, when the population standard deviation is provided, you'll just go to the formula, you'll plug in the population standard deviation, which I did here, it's 2.8. You'll plug in the sample size. In this question, it says I'm planning to take a random sample of 150 people, so my sample size is 150. It says the population I'm sampling from has 5,900 people, so my population size is 5,900. So I just plugged in all of the numbers into the formula, and all of those numbers just came from this paragraph. They were all provided to me in the question. And now I can just go through the steps of the formula. Inside the square root, I subtract on top, and I subtract on the bottom. 5,900 minus 150 is this number. 5,900 minus 1 is this number. Once I get this fraction, I just divide the top by the bottom, and I get one number under the square root. Then I just take the square root of that number. The square root of 0.975 became 0.987. I also take the square root of this part over here. The square root of 150 became 12.247. So once I take these two square roots, I'm just left with this right here. I divide, on the left side, I divide the top by the bottom of the fraction. And now I just have two numbers I can multiply to get my standard error. That's the answer. I also tell you that if the population is 20 times larger than the sample size, then you should also use the short formula. And in this problem that I have right here, the population is 20 times larger because this population of 5,900 people is definitely 20 times larger than this sample of 150. So since the population is 20 times larger than the sample in this problem, I also worked out the short formula over here. The short formula is really just sigma over square root of n. It's just the left side of the formula. So all I really did was divided my standard deviation of 2.8 by the square root of my sample size of 150. First I found the square root of 150, and that became this number on the bottom, 12.247. Then I divided 2.8 by that number, and I got my answer. So this is my answer with the long formula. This is my answer with the short formula. If the population was not 20 times larger than the sample size, then I would have worked out the long formula only, and I wouldn't have done this work over here. So when you look at the problem, you'll have to decide if the population is 20 times larger. If it is 20 times larger, work it out both ways like I did here. If it's not 20 times larger, just do the long formula only and don't use the short formula. I also gave you a couple of margin of error questions. The first one looks like this. I say that the heights of a certain population are positively skewed with a certain standard deviation, and you're planning to take a random sample of 35 people from the population, record their heights, and then calculate the mean of your sample to estimate the mean height of the population. And I give you a blank data set like this. I actually want you to fill in the data set with your own 35 numbers. So just make up 35 heights in inches and plug them in. Once you do that, you'll have to calculate your sample mean. You'll do that by just adding the 35 heights and dividing the total by 35. I'm just pretending that I did that and my answer came out to 72.71. Even though I didn't actually do the work. The next part says, can the margin of error be calculated? When you're using a sample mean to estimate a population mean, and you want to calculate the margin of error, either the population has to be normal, or your sample size has to be at least 30. If the population is normal, the sample size actually doesn't matter. But if the population is skewed or not normal, then the sample size has to be 30 or larger. In this situation, my population is positively skewed, but I can still calculate the margin of error because my sample size is at least 30. That's why I said yes. In part C, you have to calculate the 95% margin of error. If the population standard deviation is known, like it is in this question, this is the formula for the margin of error. It's the confidence coefficient, which is the letter z, times the population standard deviation sigma over the square root of sample size n. The z confidence coefficient comes from a table. The z confidence coefficient comes from a table. I'll share that table with you. But you can also remember that if I say to calculate the 95% margin of error, the z confidence coefficient is always 1.96. So this number is 1.96. Don't worry about this. This is just a subscript. The sigma is the population standard deviation, which I provided to you in the question. I'm saying that it's 5.7 because I changed the number. The little n is the sample size. And your sample size in this question would be 35 because you have 35 people. So the 1.96 came from a table, the standard deviation of 5.7 came from the question, and the sample size of 35 also came from the question. We just have three numbers we plugged in right here. 1.96, 5.7, 35. The first step is finding the square root of 35, the sample size. That came out to 5.96. Next, divide the fraction. When you divide the top by the bottom, I ended up with 0.956. Now I just have two numbers I can multiply. 1.96 times this, and the answer is my 95% margin of error. Rounded to two places, it's 1.87. Once you get the 95% margin of error, in part D I say to create a 95% confidence interval. To do that, you just have to take your sample mean from part A and add and subtract the 95% margin of error from part B. So I took my sample mean, I subtracted the margin of error, I took my sample mean, I added the margin of error, I got two answers. And then my answer is just the lower number to the upper number. That's my confidence interval. This says how confident are you that the population mean is inside the confidence interval. Whenever you create a 95% confidence interval, you're always 95% confident. So that would be the answer. Now I say to make a graph of the three possibilities. So these are the three possibilities. The sample mean could be in the lower tail, in the lowest 2.5% of sample means. Your sample mean could be in the middle, 95%, or your sample mean could be in the upper 2.5% of sample means. The first thing you need to do when you create these is draw this bell curve for the sampling distribution. Then make these lines, like I did, to mark off the three areas, the lower, the middle, and the upper. And then down here, in the middle, make a tick mark and say mu, which is the unknown population mean. Then make a line going this way and a line going this way, and label it with a 95% margin of error, which in my case came out to 1.87. That's why I labeled 1.87 and 1.87. Once you do that, in this left graph right here, put the x bar, your sample mean, in the lower tail, and draw a line like a left arm going out this way and a right arm going out this way, and label it with the margin of error. So if your margin of error was 1.87, you would put that here and that here. So the numbers that you're labeling on the two arms are the same two numbers that you have down here, because the confidence interval is the sample mean minus the margin of error, the sample mean plus the margin of error. Also, label these two tick marks like I did. See how I labeled 70.84 and 74.58? Those are the two endpoints of my confidence interval from this answer up here. So take the two endpoints of your confidence interval and label them here and here, like I did. Also label your sample mean. My sample mean from part A was 72.71. So that's my x bar. Also do this labeling, the 2.5% of sample means 2.5% of the time, right here for this area. For the middle, 95% of sample means. The sample mean will fall here 95% of the time. And over here, the same thing. Well, it's the same as the left side. In this middle graph, do everything over again, except put the sample mean in the middle area, in the middle 95% area. That way, the confidence, your confidence interval around the sample mean does cross over the population mean. So in this figure over here, your entire confidence interval around the sample mean should have been below the population mean. Over in this middle graph, your confidence interval should cross over the population mean and capture it, like mine did right here. In this graph, it's the same thing over again, except your sample mean will be in the upper tail up here, and your entire confidence interval should be above the population mean. And your confidence interval won't capture the population mean. So this is what the three possibilities will look like. Your answer will look the same as this, except you'll have different numbers than I will. I mean, you'll have different numbers than what I'm showing here because your sample mean will be different, your margin of error will be different, and your two confidence interval answers will be different. I also have another problem. I also have another margin of error problem in your homework assignment. In that problem, the population standard deviation is unknown, which means you'll be using a different formula. Just like in the first question, you'll be making up a data set. I'm telling you that you're randomly selecting 10 people and recording their heights, but you have to make up the 10 heights that are in your data set from your sample. Once you make up the 10 heights and fill them in, you have to calculate the mean of your sample. You'll do that by adding the 10 heights and dividing the total by 10, and that'll be your answer. In part B, you have to say whether the margin of error can be calculated. The rule is the same. Either the population has to be normal, or the sample size has to be at least 30. In this case, or in this problem, the population is normal. The question is telling me that the population is normal, so the answer is automatically yes. The sample size actually doesn't matter. When the population standard deviation is unknown, like it is here, there's actually a different formula for the 95% margin of error. The confidence coefficient is the letter T instead of Z. You have the sample standard deviation, S, instead of the population standard deviation, and you still have the sample size little n. So when the population standard deviation is unknown, you're substituting the sample standard deviation right here. The confidence coefficient comes from a table, just like it did before, but it actually comes from a different table. It comes from a T table. I'll explain how to look it up. I went to the T table and I found out that my confidence coefficient was 2.306. So I plugged that in for T. That took care of this part. In your problem, you actually have to calculate the sample standard deviation yourself. So what I want you to do is to take your 10 numbers and actually calculate the sample standard deviation. To do that, you just subtract each of the 10 numbers by your sample mean, which you already have from part A. I subtracted each of the 10 numbers by my sample mean of 69. I got my deviations. I squared them to get squared deviations. I just multiplied each deviation by itself. I added the squared deviations, and I divided the total by n minus 1. because it's a sample standard deviation. So use n minus 1. I have 10 people, and 10 minus 1 is 9. So I divide by 9. So I divide this total by 9, and this was my answer right here, the variance. Now I just take my variance of 36.667, I find the square root of it, and that's my standard deviation, sample standard deviation, 6.055. Now I take that number, I plug it in right here, and I need my n sample size. The sample has 10 people, so n is 10. Now I've plugged in all three numbers into the formula. Now I'm ready to go ahead and work it out. The square root of 10 is this right here, 3.162. I divide the fraction, the top by the bottom, and then I got this answer, 1.915. Now I just multiply my two numbers, and I get my answer. My margin of error was 4.42. So when you get the margin of error, you start by finding the square root, you divide the fraction, and then you multiply. Those are the three steps. Now that I have my margin of error of 4.42, I just take my sample mean for part A, subtract the margin of error, and add the margin of error. And my two answers give you my confidence interval. It's just this to this. And since it's a 95% confidence interval, I'm 95% confident that the population mean is somewhere inside the confidence interval. And when you do part F, you'll do it the same way I showed you in the last problem. You'll be labeling the three bell curves